Okay, as promised, I told you that I would go over this sheet here, the geology review, in case you all had any questions about this, and so that you can check your work so that you're prepared for your test. So, if we look at the first part that has diagram 1, it says follow the directions and answer the following questions for the below diagram. So I am looking here where it says color the youngest layer green. So remember, your youngest, always young above old. So your youngest layer is layer L. So that would be this. And then it says color your oldest layer orange. Your oldest layer is at the very bottom. So that's this here. Highlight the fault. I don't have a highlighter with me in front of me, so I'm just going to highlight it in this yellow, and that's your fault. What is a fault? A fault is a break in rock or Earth's crust. I'll just put a break. And then listing the order of law according to law of superposition. What came first is the oldest, which is D, then H, then L, then P. All right, moving on. I'm at number 2, diagram B. For the below diagram, use the information provided to label the rock layers. So the oldest is J. This came first, then M, then D. I'm sorry, not D. This is D. Let me start over. I apologize. I'm not paying attention. I'm sorry. J is here. This fault here affected only J. So this is M, then D, then P. Now this could be L or A, and this could be A or L, only because this did not affect this. And what happened was the tilting came about, which allowed the space for this layer. So it really can't tell with the picture which one came first. All right, the law of superposition. Here, if you just had young above old, that would be fine, but it's young rocks above older rocks in an undisturbed fashion. I skipped a number. I went to 4, so I'm going to go over to 3. Answer the below questions. What is F pointing to? This is F here, pointing to this squiggly line here, and that is an unconformity. Describe how F has occurred. F either has occurred through erosion or non-deposition. All right, diagram D, we're going to use this diagram here, and it says describe what has happened to the rock layers P, K, and B. They're tilted. Of the 2 disturbances, what kind of disturbances are P, K, and B? These would be events. What is J, which is pointing to this here? And J is a fault. T is this area here. That is an intrusion. And of the 2 types of disturbances, what are J and T? These are features. Using the law of superposition, we're going to color the oldest layer blue. Oldest layer would be layer S. So this should be what's blue. color the youngest layer yellow. The youngest layer is G. Is T older or younger than the layers S, H, and U? Here's T. Is it older or younger than S, H, and U? It is younger. Wrong spot. Younger. Because it affected S, H, and U. Is J older or younger than T? J came after T, or did T come after J? T came after J because J did not affect T. So therefore, J was first. So J is older. List the order of occurrences. So first we have S, then there's H, this is an H, then there's U, then there's J, because remember J is older, then T, then there's B, K, P, U. All right. We're going to fill in the blanks for the geologic column. A geologic column is a stack of rock layers gathered from many small layers or parts from all around the world. Arranged in order, at the bottom is oldest, 2 at the top, youngest, representing the layers of the earth or world. The geologic column is used to find the age of the earth. All right, moving to the back. Some rock layers may contain fossils. An index fossil is located in one layer or one geocolumn. Index fossils can be used to find absolute age using radiometric dating, and they are measured in half lives. All right, let's now look here. List the relative, let me just make sure you see these are X's. We're going to list the relative age of the fossils from oldest to youngest. So when we look here, we have triangles and circles, but circles continue, so our triangles come first. Then our circles show up. Then we have stars. I'm sorry, these are diamonds, silly me. Diamonds, not triangles. Then we have triangles. Then we have rectangles, which continue in this era. But we also have X's and half circles, but the X's continue, the half circles do not. So half circles are there, and then our X's. This is a star. Which of any fossils can be used as index fossils? Remember you said index fossils were the fossils only in one geocolumn. Well, diamonds are only in one geocolumn, so we know that's it. Diamonds is nowhere else. Circles are here, here, and here. Stars are here and here. Triangles are here and here. Rectangles are here and here. Half circles are only here. And X's are in both, so there we are. What method would be required to determine absolute age? radiometric dating. And then here it says, if your index fossil contains 3.125 plutonium, which has a half-life of 2 billion years, how old is the rock layer that contains it? Well, we have to move from, we know that in the very beginning we have a hole, so that's 100%. After 2 billion years, we are at 50%. After another 2 billion years, we are at 25%. After another 2 billion years, we are at 12.25%. After another 2 billion years, okay, I'm sorry, here I apologize, it's 12.5, not 12.25, silly, 12.5%. After another 2 billion years, we're at 6.25%. And after another 2 billion years, we are at 3.125%, which is the amount that was there when we dug it up. So therefore, how much time has passed from 100% to 3.125%? 2, 4, 6, 8, 10 billion years. All right, down here it says carbon's stable state is C14 with a half-life of 5,730 years. What fraction of the original C14 remains in a sample after 11,460 years? So, this C14 is just the name of the stable state. That 14 means absolutely nothing. So, we have one hole in no time. This is 0 time has passed. After time has passed, the half-life is 5,730 years. After that 5,730 years, we now have a half. Over another 5,730 years, we are going to have a fourth. How much time has passed from there? Well, let's take a look. We have two sets of 5,730 years. That is totaling 11,460 years. So the amount that remains is 1/4. Potassium's stable state is K40 with a half-life of 1.3 billion years. How old is the sample? Is a sample that contains 25% of the original K40. Remember, K40 is the stable state. That's the name of the potassium. We do not have to recognize the number 40. So, it says it has a half-life of 1.3 billion years. How old is the sample if it's at 25%? Well, we start off with the 100%. A half-life passes, which is 1.3 billion years. We're now at 50%. Half-life passes, which is another 1.3 billion years. We are now at 25%. That's the amount that we're looking for. How much time has passed? 2.6 billion years. All right, this is T-Dubs signing off. Good luck, and if you have any questions, leave comments below, and I will answer them back. All righty.